Hi everyone, I'm Brian Semple from Markforged, and I'm here with...
Hi, I'm Nick, a content engineer here at Markforged.
So we're down at SolidWorks World 2019, and we're currently not there right now, but there are people down there right now. We're getting a bunch of questions about exactly how does the Markforged metal printing system work. So I thought we'd grab Nick here real quick, and we'll give you a quick run through of Metal X. Fire away, Nick.
Sure thing. So this is the Metal X 3D printer, and how this works is we have metal powder that's bound in a wax and thermoplastic matrix. And so that allows us to put it on a spool, much like other FFF processes you've seen in 3D printing. And that's extruded, heated and extruded through a print head, and then built up layer by layer into a part, which is what we call a green part. And here's an example of one right here.
So basically we're using similar technology, it sounds like, that we're using with our composite printers, except we're doing metal powder.
Exactly. So our first composite printers came out a little over 5 years ago, and we basically perfected that technology and inserted that into the metal space to make a more office-friendly version of a metal 3D printer, essentially.
And of course, the other difference is on some of our composites, we also run secondary continuous fiber reinforcement, which of course we're not doing here.
Exactly.
Okay, so you get this part out, and is this finished?
So this is not finished yet. As I mentioned, this is called a green part. So once you get this part out of the printer, it still has that plastic and wax matrix bound within it. And so what you do is you take this green part and you put it into our wash. And what this wash does is it starts to debind the wax out of the part. And when it comes out, it actually looks very similar to a green part, but then it's called a brown part. And so what you do with that brown part is, to finish it off, you stick it in our sintering oven, which is over here. And the sintering oven, what that does is incinerates all that plastic binder that's left in there, and then melds the metal powder together to get a full density metal part. And so what that looks like is here. These are examples of parts of an end effector for a robot arm. And as you can see, there's some significant shrinkage here. It shrinks about 20% in each dimension, and that's because the plastic that's in there gets incinerated out and it shrinks down as the metal powder binds together.
So common question we get is, how do we accommodate for the shrinkage when we design the parts?
Yeah, that's a great question. We have a bunch of really intelligent software people. So basically what you do is you put in your final dimensions that you want in your part, and the printing algorithms automatically scale up the part so that your green part is the size it should be to go into the sintering oven and get you down to the dimensions you originally requested.
And that software, of course, is Eiger, which is our cloud-based software. We've got a large cloud infrastructure up there of running some super smart software that allows you to go do all those pieces. Okay, super. So it shrinks down. Eiger takes care of it. So what materials are we currently printing?
So right now, this is 17.4 pH stainless steel, and that's what's printing right here. This is just a tensile test dog bone that's printing right now. And we're also printing in H13 tool steel, which is really good for those high heat and high impact use cases. And so we're looking in the future to start printing a couple more tool steels like A2 and Inconel as well, which is a high nickel alloy. And then even further in the future, looking to print titanium.
All right, great. So we got some cool applications over here. Anything you want to share with folks in terms of some sample metal parts that have been printed on the printer?
Yeah, definitely. So here's an example of an end-use part that one of our customers prints, Stanley Black & Decker. They print this actuator housing, which goes on a post driver. And so this used to be a 4-part assembly, and now it can be printed just as one solid part.
Is that an injection mold I'm seeing over there?
Yeah, so this is an example of a printed injection mold. And so one giant advantage to 3D printing in general, not just metal 3D printing, is compressing your tooling manufacture process. So you can design and iterate on tooling a lot faster, which saves you a lot of money. And so prototyping injection molds and then eventually printing your injection molds that you're actually doing shots out of is a really good way to accelerate that tooling process.
And actually, injection molding has been one of the applications that we get a lot of questions on. Actually, sometimes people will look at this thing, they'll look at the materials, they'll look at stainless, then they'll say, oh, you do tool steel? And then the next question is, what about injection mold?
Yeah.
So that's a really large area of application for this. So that is our Metal X system. So it is shipping today. You can buy it today. We can ship it to you. I don't want to make any commitments for the manufacturing team, but we could probably ship it to you in a couple weeks. There is a backlog, but we can get it out to you. There's customers out there. In fact, we're shipping several hundred of these units right now out to customers. The total price for all three of these, when you factor in installation, 3-year success plans, you should probably count on maybe $150,000, $160,000 US dollars in the US. Prices will be different in other parts of the world. You need to have you can get about 3 printers, can drive about 1 wash station and 1 sinter. Again, it's going to depend upon the types of materials that you print. You can always get your own an incremental printer for about $100,000. Again, you need to add on installation and success plans on top of that. So very, very affordable, high quality, 3D printing, metal that anybody can use. Did we get everything?
Sounds great.
Great, thanks so much. Enjoy the rest of SolidWorks World.